Good evening once again. Oh, sorry, it's good night already. Okay. I hope everyone is doing well. Let us follow or let us begin with the solutions for the 11th video on homework portal. Okay, my name is Rasankar Rao. I teach physics in an international school in Bangalore, and the videos that you will see here are all the homeworks which I provide to my student every day, 5 MCQs, and I ask them to solve these problems, at least 5 questions, so that they get an edge on the topic of mechanics. So currently we are solving only problems on mechanics, and shortly I'll be starting with the rest of the problems. Okay, let us begin. Right. So as you see here, this is my main website. You can access all the websites, or you can access all the videos that I have posted so far. And if you want to directly take up these videos, I can directly link it to over here also. Okay, it is better that you visit my website, get to know more about me, and then you can look into it. Okay. So let us begin. So as I had discussed everything yesterday, now let us start with this. The length and the side of a cube is 2 centimeter plus or minus 4%. So what is given here? Cube A is given by 2 centimeter plus or minus 4%, which is nothing but A0 plus or minus delta A by A percentage. Then mass of the cube is given by 24 grams plus or minus 8%, which means I am given M0 plus or minus, what is this now? Delta M by M percentage is also given. What is the percentage uncertainty of the density of the cube? Density of the cube is asking you to find out delta rho by rho into 100. This is what has been asked. So towards it, what is rho? First, what we will do is we will take up the value of rho. Rho is nothing but mass by A cube, right? And thus delta rho by rho is equal to delta M by M plus 3 times delta A by A, which should now be equal to, what is delta M by M? Delta M by M is 8%. 8% plus 3 times delta A by A. That is delta A by A, 4% plus 3 into 4, which should now be equal to 8 plus 12, which should be equal to 20%. So the answer is plus or minus 20%. Okay. So now let us solve the next problem. A truck has an initial speed of 20 meters per second. What is given here? U is given. It decelerates at a rate of 4 meters per second square. A, which is minus 4, is given to you. U, which is equal to 20, is given. What is the distance taken by this truck to stop? Now, which equation will you use? See, the deceleration is minus 4 meters per second square, which means what? It's a constant acceleration. So you can always use equations of motion, right? Until unless we are describing a problem based on the constant acceleration, you can use your equations of motion. Now, so which equation will we use? What is the distance taken by truck to stop? Yes has been asked. Now, which equation relates S, U, A, and then I'll also tell you, see, it says to stop, which means V equal to 0, and V, which is nothing but V square equal to U square plus 2AS. Now, what is V? 0. This should be equal to U square. What is U square? 400, 20 square plus 2 into what is A? Minus 4. What is S? Unknown. So you need to find out this. So 400 should be equal to 8S. This implies S should be equal to 400 divided by 8, which is equal to 50 meters, right? So the answer here is C. Okay, now let me move on to the next one. A runner starts from rest. Runner starts from rest, which means what? U equal to 0. And accelerates. Accelerates, it means at a constant rate, which means what? You can apply your equations of motion through a race. Which graph shows a variation V? Variation V of the runner traveled with the distances, which means what? He is asking you, how does V proportional to, how is V dependent on S? That's what has been asked. Which equation you can use? The previously also we used the same equation, right? Which is nothing but V square equal to u square plus 2as. Now you see it starts from rest, so I can just write it as 2as over here. V square equal to 2as. Now when I have v square equal to 2as, now what kind of graph can it be applied? Can we apply this one here? See this, which means that v is proportional to root s. This is what I get here. Can I apply this? No, this cannot be applied. Can I apply this? No, this can also cannot be applied. Now it should either be of A and C. Now which one will I apply? So that's what we need to look at. Now an easy test for it is just choose v square is equal to 2as. If v is positive, s is positive, right? And if v is negative, still s is positive because negative a square becomes positive s. Look at this, right? So if v is positive, s is positive. If v is negative, s is negative. Which one could be used over here? S is positive. Once again, okay, let us say for example, if v is negative, v square would be positive. V square will be positive, so you will get this one here. Okay, and as a result of it, s is once again positive. Will the s be positive for this? See, s is negative in this case. So this is impossible. Let us look at this here. If v is positive, okay, you get this value of s. If v becomes negative, what means? That means you should get a graph like this, right? Which means what happens here? For every negative value of v, see, for every negative value of v, if you look at the value of s, s is always positive, right? So therefore, v square equal to 2as corresponds to this parabolic arc. So therefore, answer A is the right option. Then, next, a projectile is fired at an angle to the horizontal, the path of the projectile is shown. Okay, the projectile is fired like this. Now, see this one is going up in a proper way. Now, suddenly there is a fall here. How should the fall be? Now, let us say it is the maximum point. It should have gone like this over here. There should be a symmetrical curve. But why it is not symmetrical? Maybe, see, when will it not be symmetrical? You should ask this. It will not be symmetrical when the particle, the moment it comes over here, it's been dragged constantly like this. It's been dragged constantly like this. And as a result of it, fall down here. Okay, which gives the magnitude of the horizontal component and the magnitude of the vertical component of the velocity of the projectile between O and P. Now, what is your answer here? Vertical component. What happens to vertical component here? Here, what happens is the vertical component starts increasing from O to P. So, therefore, increasing from O to P, which means what? Either, just a moment, I have to move this up, please. Yeah, either this and this will be correct. So, these two are incorrect. Let me put it at this. Now, vertical component, definitely these two are incorrect. Now, what will happen to the horizontal moment? Horizontal velocity. If it had gone like this, good, horizontal velocity remains a constant. But unfortunately, it did not go like this. So, horizontal velocity has decreased over here. Okay. So, therefore, this is also increased. This is also incorrect. So, the A is the right answer. Okay. So, I hope you understood this. Okay. If not, you can put back to me in the comments box. I will put across the relevant equations, or maybe you can write back to me. I can help you out with this. Right. A mass M is attached to a string of length R. Now, it's a circular motion problem. A mass is attached to the length with radius R. Okay, and the moves in a vertical circle with a constant speed. The tension in the string at the top of the circle is T. At this point, it is T. So how is the tension acting? See, this is the mass M here. It should be pulled. It should not be pushed. Okay, it's pulled like this. This is a tension T here. What is the kinetic energy of the mass at the top of the circle? What is the kinetic energy at this point? That's what is the question. So how do we do this? So to get this, what do we need? We need to get half mv square. Simple. Okay, so towards it, what we do is we'll write T plus, or maybe how do we write this? Okay, T plus mg should now be, okay, I think I got disconnected in between. Let me reshape it. Right. Okay, so now we have this. Now we need to solve this. How do I solve it? Okay. Now, what is the free body diagram for the object here? Tension is acting downwards. Mg is also acting downwards. T plus mg is equal to, there's a net force. What is this? Mv square by r. Okay. So that's the reason why it is going down like this. Now, what is being asked? he has asked you to find out the kinetic energy. Okay. So now what I will do is I'll write this as mv square is equal to r into t plus mg. Okay. I'll take this r, push it on the other side. Now what do we need? Kinetic energy. Kinetic energy is nothing but half mv square. So multiply this by 4, which should be r by 2 into t plus mg. R by 2 into t plus mg, which was the option A, right? Okay. So this is how you arrive at it. Problem appears to be very easy. There's nothing more being asked, but you need to read it appropriately. The kinetic energy at the top is equal to so much. Okay, so we have come to the flag end of the questions for today. So next day, tomorrow, we will continue with some more problems. Thank you, friends, for watching this video until the end. And do like, share, and subscribe to my channel to get more updates. Mostly in the month of April, I'm starting all the videos related to concepts. Okay, in physics, could be useful for those who are studying for JEE mains. So let us begin. Okay, thank you, friends. Thank you once again.